Picture this, you're cruising at 37,000 feet, sipping your coffee, when suddenly the plane starts bouncing like it's driving over speed bumps in the sky. Your heart races, your grip tightens on the armrest, and you glance out the window to see the wings flexing and bending with each jolt. Everything in your body is screaming that something is very, very wrong. By the end of this video, you'll understand exactly why turbulence happens, why it feels so terrifying, and most importantly, why it's actually proof that your plane is working exactly as designed. We'll explore everything from invisible atmospheric rivers moving at 200 miles per hour to why a spilled drink is often the most dramatic consequence you'll actually experience during turbulence. To understand turbulence, we need to think about air completely differently. Most people imagine air as empty space, but it's actually more like an ocean made of invisible currents, waves, and whirlpools. The atmosphere has layers, temperatures, and pressure differences that create a complex, three-dimensional highway of moving air masses. If you've ever tried to ride a bike on a windy day, you've felt how moving air can push you around, slow you down, or give you a sudden boost. Air does the same thing to airplanes, but it's a three-dimensional maze of currents moving in different directions and speeds. The jet streams alone are ribbons of air moving at speeds up to 200 miles per hour, snaking around the globe like atmospheric superhighways. When your plane encounters the edges of these streams, it's like a boat hitting the wake of a much larger ship. According to recent research from the University of Reading, these jet streams are becoming more volatile due to climate change. Clear air turbulence has increased by 55% since 1979 over the North Atlantic, one of the world's busiest flight routes. But here's the key point. Even with this increase, turbulence remains one of the safest aspects of flying. The numbers tell an incredible story. Each year, approximately 58 people in the United States are injured by turbulence while not wearing their seatbelts. To put that in perspective, more people are injured by their toasters. But why does something so statistically harmless feel so absolutely terrifying? Evolution programmed our brains for survival on the ground, not 7 miles above it. When turbulence hits, every instinct screams that something is wrong because our ancestors never had to deal with sudden drops while hurtling through the sky at 500 miles per hour. There's a fascinating psychological phenomenon at play here. When you're driving and hit a pothole, your brain processes it as normal road irregularity. But when a plane hits an air pocket, that same bump triggers our fight or flight response because we have no control and no visual reference for what's happening. Add to this the fact that turbulence often happens without warning. You can see a pothole coming, but clear air turbulence is completely invisible to radar, satellites, and the naked eye. It's like hitting an invisible speed bump in the sky. Here's the key point to bear in mind. The intensity of turbulence that passengers find terrifying is actually quite mild from an engineering perspective. What feels like the plane is falling apart is typically just light to moderate turbulence. Severe turbulence, the kind that can actually cause structural stress, is so rare that most commercial pilots will encounter it only a few times in their entire careers. The Federal Aviation Administration data shows that between 2009 and 2022, only 34 passengers and 129 crew members were seriously injured by turbulence. Most of those injuries, people who weren't wearing their seatbelts. Turbulence isn't random chaos, it's physics in action. There are 4 main culprits that create these invisible bumps in the sky, and understanding them reveals just how predictable and manageable turbulence really is. First up, mechanical turbulence. When air hits mountains, buildings, or even other aircraft, it creates eddies and swirls, just like water flowing around rocks in a stream. Mountain wave turbulence can extend 5 to 30 miles downwind from peaks, which is why flights over the Rockies or Alps can get bumpy even in clear weather. Second, thermal turbulence. As the sun heats the ground unevenly, it creates rising columns of warm air called thermals. These invisible elevators of air air can boost glider pilots to incredible heights, but they feel like speed bumps to commercial aircraft. Third, wind shear turbulence. This happens when air masses moving at different speeds or directions meet. Imagine two rivers flowing at different speeds, suddenly merging. That's essentially what's happening in 3 dimensions around your plane. And finally, the most notorious clear air turbulence. This invisible menace forms near jet streams, where fast-moving air creates vertical wind shears. Recent studies show that climate change is intensifying these jet streams, making clear air turbulence more frequent. But here's the remarkable part. Pilots have tools to handle all of this. Modern aircraft are equipped with weather radar that can detect precipitation and storm systems. Air traffic control systems share real-time reports from other aircraft. And when pilots do encounter unexpected turbulence, they have specific procedures and speeds designed to keep everyone safe. The turbulence penetration speed, for instance, is a carefully calculated velocity that protects the aircraft's structure while maintaining control. It's like having a speed limit for bumpy roads, but for the sky. This is where smart engineering design comes into play. Commercial aircraft aren't just built to handle turbulence. They're designed to handle forces far beyond what passengers will ever experience in normal flight operations. Every aircraft must pass what's called the gust envelope test. This means the plane must be able to withstand a vertical gust of 66 feet per second, which is roughly equivalent to a 45-mile-per-hour updraft hitting the aircraft vertically. In the real world, these conditions are extraordinarily rare. But the safety margins go even further. Aircraft structures are designed with a safety factor of 1.5, meaning they can handle 150% of the maximum expected load before any permanent damage occurs. Think about this. When you see those dramatic videos of airplane wings flexing during turbulence, that's not a sign of weakness, it's a feature. Modern aircraft wings are designed to bend, with newer designs capable of bending well over 20 degrees before braking. That flexibility is what allows them to absorb the forces of turbulence rather than transferring all that energy to the cabin where you're sitting. Boeing and Airbus put their aircraft through tests that would make a roller coaster designer nervous. They bend wings until they snap just to see how much force it takes. The result? Modern aircraft can handle forces of 3.7 Gs before reaching their structural limits. To put that in perspective, even the most severe turbulence rarely exceeds 1 G of force. A typical bumpy flight experiences forces of just 0.1 to 0.3 Gs. You experience more G-force during a sudden sneeze. The materials science behind modern aircraft is equally impressive. Carbon fiber composites and advanced aluminum alloys create structures that are simultaneously lighter and stronger than anything used in aviation's early days. These materials have what engineers call damage tolerance, meaning they can develop small cracks or imperfections without catastrophic failure. But the real game changer is the global network of aircraft reporting systems. Every few minutes, aircraft around the world automatically transmit their location, altitude, and weather conditions. This creates a real-time map of atmospheric conditions that's updated continuously. When pilots encounter turbulence, they immediately report it to air traffic control, including the intensity, altitude, and location. This information is instantly shared with other aircraft in the area, creating a collaborative early warning system. Pilots also have specific procedures for different types of turbulence. For mountain wave turbulence, they might climb or descend to find smoother air. For thermal turbulence, they'll often request a higher altitude where the air is more stable. For jet stream turbulence, they might ask for a route change to avoid the worst areas. And here's something most passengers don't know. Pilots actually slow down when they expect turbulence. That turbulence penetration speed we mentioned earlier, it's typically 20 to 30 miles per hour, slower than normal cruise speed. This isn't because the plane is struggling. It's because slower speeds reduce the stress on the aircraft and provide better control. Modern autopilot systems are also incredibly sophisticated. They can detect and respond to turbulence faster than any human pilot, making dozens of tiny adjustments per second to keep the aircraft stable. It's like having a pilot with superhuman reflexes. Let's talk about the statistics that should put every nervous flyer at ease. Since 1980, there have been only 6 fatal turbulence accidents involving commercial jet airliners worldwide. 6 in over 4 decades. During that same period, billions of people have flown safely through turbulence that felt terrifying but caused no structural damage whatsoever. According to the National Transportation Safety Board, turbulence accounts for about 75% of all weather-related aviation incidents. But here's the crucial detail. Most of these incidents are minor injuries to passengers and crew who weren't wearing seatbelts. We're talking about bruises and sprains, not structural failures. The data shows that turbulence injuries occur primarily in 2 situations: passengers using the restroom or moving around the cabin, and flight attendants performing service duties. Modern aircraft encounter moderate or greater turbulence on about 65,000 flights per year globally. That sounds like a lot until you realize there are roughly 100,000 commercial flights every single day. So statistically, you have about a 0.18% chance of experiencing anything more than light turbulence on any given flight. Even when severe turbulence does occur, passenger aircraft are designed with such robust margins that structural damage is virtually impossible. The physics simply don't allow for it. Here's a comforting comparison. You're statistically more likely to be struck by lightning than to be seriously injured by aircraft turbulence. You're more likely to find a pearl in an oyster at a restaurant than to experience turbulence severe enough to cause structural damage to a commercial aircraft. Climate change is writing a new chapter in the turbulence story, and it's not what you might expect. Research from leading atmospheric scientists shows that clear air turbulence is indeed becoming more frequent and intense. The jet streams that create this invisible turbulence are becoming more volatile as temperature gradients between different regions of the planet increase. Some projections suggest that severe clear air turbulence could double or even triple in certain regions over the next few decades. Over busy routes like the North Atlantic, moderate turbulence has already increased by 37% since 1979. But here's the fascinating paradox. As turbulence becomes more frequent, flying is actually becoming safer. Modern aircraft are better designed than ever before. New materials, advanced computer modeling, and decades of accumulated data have created aircraft that can handle conditions that would have been challenging for planes from previous generations. The aviation industry is also developing new technologies specifically to address increased turbulence. Enhanced weather radar systems can detect clear air turbulence patterns. Improved forecasting models can predict turbulent conditions hours in advance. And next-generation aircraft designs incorporate even more sophisticated systems for managing atmospheric disturbances. Some experimental systems can actually detect turbulence using LiDAR technology, essentially giving pilots the ability to see clear air turbulence before the aircraft encounters it. It's like having X-ray vision for invisible atmospheric disturbances. The bottom line, while climate change might make the skies bumpier, the engineering response is making aircraft safer and more comfortable than ever before. It's an arms race between nature and engineering is winning. So what can you do as a passenger to make turbulence less stressful and safer? The most important advice is also the simplest. Keep your seatbelt fastened whenever you're seated. This single action eliminates virtually all risk of turbulence-related injury. Choose your seat strategically. Seats over the wing experience less motion during turbulence because that's near the aircraft's center of gravity. Stay hydrated and avoid alcohol. Dehydration and alcohol can make you feel worse during turbulence and can affect your balance if you need to move around the cabin. If you're a nervous flyer, try this mental exercise. Remind yourself that turbulence is simply the aircraft doing exactly what it was designed to do. Those bumps you feel aren't signs of danger. They're proof that the aircraft systems are working perfectly to keep you safe. Watch the flight attendants. They experience turbulence on dozens of flights every month. If they're calmly serving drinks and chatting with passengers, you can be confident that what you're experiencing is routine. And here's a fun fact that might help. Pilots sometimes encounter turbulence deliberately. When testing new routes or investigating weather patterns, they'll fly through areas of known turbulence specifically to gather data. If turbulence were genuinely dangerous, this would be unthinkable. Finally, remember that turbulence has never caused a modern commercial aircraft to crash due to structural failure. Not once. The physics simply don't allow for it, given how these aircraft are designed and built. As we wrap up our journey through the science of turbulence, let's appreciate the incredible achievement that routine air travel represents. We've covered how atmospheric dynamics create invisible highways of moving air, how evolution makes turbulence feel more dangerous than it actually is, and how modern aircraft are built with safety margins that exceed anything nature can produce. We've seen how pilots have tools and procedures that turn turbulence from a threat into a minor inconvenience, and how statistical analysis shows that your biggest risk during turbulence is spilling your drink, not any actual danger to the aircraft. Climate change might be making the skies bumpier, but human ingenuity is making aircraft safer. It's a testament to our species' ability to solve complex problems through science, engineering, and collaboration. The next time you're on a flight and encounter turbulence, try to see it for what it really is, a demonstration of humanity's mastery over the physics of flight. You're sitting in a metal tube traveling at 500 miles per hour, 7 miles above the ground, surrounded by invisible rivers of air moving at different speeds and directions. And yet you're safer than you would be in your car driving to the airport. That's not just impressive, it's miraculous. What questions do you have about turbulence or aviation safety? Share your thoughts in the comments below. And if this video helped ease your flying anxiety even a little bit, consider subscribing for more deep dives into the fascinating science behind everyday experiences. Until next time, keep exploring, keep questioning, and remember, sometimes the things that feel the most dangerous are actually proof that everything is working exactly as it should.